Eleanor Rigby picks up the rice at a church where a wedding has been. Lives in a dream, waits at the window, wearing the face that she keeps in a jar by the door. Who is it for? All the lonely people. Where do they all come from? All the lonely people. Where do they all belong? Alright, so we are going to talk about a golfer. We are going to talk about a baseball player. We're going to compare home runs versus golf scores. So the question is, Jason versus Jen. Let's say Jason hits 27 home runs in a season, and Jen averages a 65 when she golfs. So the question is, who done better? I want you to pause the video and think about that and do your best to come up with a solution. Father Mackenzie writing the words of a sermon that no one will hear. No one comes near, look at him working, donning his socks in the night when there's nobody here. What does he care? All the lonely people, where do they all come from? All the lonely people, where do they all belong? Yeah, maybe I should start a Kickstarter. Get my music career going. Ladies and gentlemen, what do you think? What do you think? Yeah, I know probably not. Probably a bad idea. So let's take a look at the pure data. Obviously, Jason hits less home runs than Jen's golf score, but that doesn't matter. What we need to do is compare to the average. Right? So, let's think about it. Jason's X value is 27. Let's say Jen is Y. And her Y score is 65. So the question is, Jason beats the average by 13. So Jason is plus 13, which is good. Remember, in a golf score we want a lower score. Jen is minus 3, which is good, right? But the problem is that minus 3 more impressive than the plus 13? Because remember, we need to also look at the spread of the data. The golf scores are more compact, so doing 3 better at golf is much more impressive than 13 better in the home runs. So let's take a look at the z-scores, the amount of standard deviations above or below the mean. So for Jason, his z-score, remember that's x minus mu over standard deviation. That'd be 27 minus 14. And remember, that's where we get that plus 13. So this makes total sense. And then we divide that by 10. So his z-score is, drumroll, awkward, 1.3. So in context, Jason is 1.3 better than the mean. Now let's look at our buddy Jen. Now her z-score would be 65. Well, let's write this as an equation. Y minus mu over standard deviation. So that's 65 minus 68 all over 2. Well, that's negative 3 halves, which is negative 1.5. So Jason's z-score is better, right? Because 1.3 is bigger than negative 1.5. Remember that a lower score is good in golf and a higher home run total is good in baseball. So the negative 1.5 is more impressive because she is 1.5 better than the mean because a lower score is good in golf. So at first you might have thought, well, Jason, that's 27 home runs versus 14. He's like doubled the average. But you have to look at the standard deviation. So Jen is more valuable, is a more impressive golfer than Jason is as a home run hitter. So there you go. That's how you use z-scores to compare the means. What you want to think about is whether or not you want a positive or negative z-score. Then use the equation. Do you want a high score or a low score? All right, that's about the time that I've got for you today. Good luck on your formative assessment. It's going to be great. Go Badgers.